double right.
Hi, hello students, good evening everyone. I hope all are doing well. Anyway, warm welcome all of you to the Infinity Learn JEE YouTube channel. This is me Surya, your chemistry faculty from Infinity Learn. Hi Anish, good evening. Okay, today in this particular session we are moving to our new chapter, new topic from the physical chemistry chapter, that is thermodynamics. It is very important. We can explain these thermodynamics topics with the examples, real life examples, right? Daily life examples. Okay, fine, let's start first. Okay, what do you mean by thermodynamics? Any idea? What does the word mean, thermodynamics? Thermo means heat, right? Thermo means heat, or otherwise I can say that this is the word. It can be split into, this is heat, and dynamics means anything that is related to motion, right? Moving or motion. Then now I have a question for you. Do you think, does heat moving? Change or cause involve temperature. Yeah, you can say like that. Otherwise we can say that, simply we can say that by the name itself, thermodynamics means heat that is moving, right? Okay, here you can see some pictures, right? This is one picture. Here I am just handling, I am just lighting the one of this will be the metallic rod. So after some time I can see that this end is also become hot. Why does it happen? Any idea? Because I am starting lighting from here, that side only. But after some time heat is going from here, right? That's why this end become very hot. Which means that heat is moving, right? Heat is moving. Then is there any other examples? Does heat moves? Again, this is a tea time, right? So if I am taking a cup of tea, whether tea or coffee, I am saying like that, I am just keeping the cup of tea or mug of tea for a few times. What will happen? It will cool down, right? It will cool down, which means that heat is transferring from here, right? Whenever I am keeping a cup of tea here, the heat is transferring from here, which means that heat is directly moving, right? Okay, fine. So that we can just define the thermodynamics as it is the branch of chemistry which deals with the study of heat, right? Thermo means study of heat and their interconversions. We can just convert heat into other forms of energy, right? So the study of heat and their interconversions are commonly known as the thermodynamics branch, right? Thermodynamics branch. We will be leading with the thermodynamic themes in detail in this particular session. Then we will be going from the basics to advanced level of thermodynamics. Ready? Hi Shivansh, good evening. Okay, now let us start with the thermodynamic term. What do you mean by a thermodynamic term? For example, if I am taking a bottle of water here, right? I am taking a bottle of water here. Now I am explaining that I am just taking some reactions happening about this bottle of water. So if I am taking this container of water or bottle of water, I can say that this is under steady, right? This bottle of water is under steady, and all the space surrounding here, right? It will call it as a surrounding. Or otherwise, we can say that any thermodynamic system can be converted into two types, right? System and the surroundings. For example, if I am taking the water bottle here, a bottle of water, I can call it as a system, right? Then any part of this universe that except which is other than this bottle part of bottle, right? Water bottle, we can call it as a surrounding, right? So we can just define the thermodynamic system, right? It is a part of the universe, which means that it including system as well as surrounding. It is a part of the universe which is under thermodynamical study, right? Which is under thermodynamical study is called the system. Then all the part other than or remaining part of the universe which is in contact with the system is called the surroundings. Clear? Are you getting my point? What you mean by system and the surroundings? For example, if I am taking a beaker of water here, just assume this is a beaker. Okay, this will be the water. Now, I am keeping this bottle of water under steady. So, I am taking this as a system, right? This will be a system. Then all the part surrounding this system, other than this beaker of water, I am calling it as a surrounding, right? I am calling it as a surrounding. So, in total, including this system and the surrounding, I can call it as an universe, right? I can call it as an universe. Right? Clear? Then, as you can see here, this is a beaker, right? This is a beaker. So, I can say that there is a real or imaginary boundary in between system and the surrounding. Let us say, in this case, beaker will be the boundary, right? Beaker will be the boundary. So, we can say that there are the more important terms related to the thermodynamics. First one is the system, right? The part of the universe which is under steady is known as the system, and all the other part of universe other than system is known as the surrounding. Then in total, the system and the surrounding is known as the universe, and system and surrounding is separated by a real or imaginary boundary. Clear? Yes, boundary or wall. Also you can call it as a boundary or wall. Clear? Yes, fine. Now, let us see what are the different types of systems, right? Depending upon the heat exchange or energy exchange, how we can define the different types of systems. Okay. Here you can see a beautiful picture, right? Which is taken from our real life example. So, this is the tea time. So, I am taking a cup of tea here. As I can say here it is heat is going, right? Heat is also changing here. As well as mass or matter is also changing here, right? Mass or matter is also changing here. So, we can call this system as an open system, right? Open system. Yes, Pooja, you are correct. There are three types of systems present, right? What are they? Open, closed and isolated system, right? So, if I am taking a cup of tea, I can say that in the case of a cup of tea, heat as well as matter is exchanging, right? So, such type of system which contain heat as well as matter exchange happens is known as the open system, right? It is open. Now, what about the closed system? Closed, right? Now, the same cup of tea, I am just closed by using a lid or any cover like that, right? So, what will happen here? There will be heat exchange happening, right? Because of these walls, heat exchange will happen, but there is no any matter exchange, right? There is no any matter exchange. So, I can say that this type of system is known as the closed system, which means it is closed by using a lid. Clear? Okay, now what about the third one? Isolated system, right? Isolated. What do you mean by isolated? It is completely isolated, right? It is different from the system. And yes, there is no any mass exchange, right? There is no any mass exchange, as well as there will not be any heat exchange also, which means energy exchange as well as matter exchange will not happen in the case of isolated system. Here you can see this is a thermos flask, right? Thermos flask we are used to keep hot water, maintain the heat, continuous, right? Make the heat constant. We make the heat constant. We are using the thermo flask. So in the case of a thermo flask, we can take it as an isolated system. Clear? Okay, depending upon the heat as well as matter exchange, systems are classified into three types. Open system, which means matter as well as heat exchange happen, right? Heat or energy exchange happen. Then what about the closed system? Whenever we are closed by using a lid or something, we can say that there is no any matter exchange, but there will be the heat exchange or energy exchange, right? Then the third case, it is the isolated system in which there is no any heat exchange as well as matter exchange. Clear? The same picture is given here. I mean, same type of picture is given here. This is the open system. A conical flask containing water. We can say that the wall is not insulated, which means that heat exchange is also happening here, as well as mass exchange is also happening here. Then what about the second one? There is no any mass exchange, but heat exchange is here. Third one, there is no mass exchange as well as heat exchange because of the presence of an insulating wall. Insulating means there is no conduction, right? Insulating means there is no any heat exchange happening. Clear? Okay, fine. Now let us move to the next terminology which is related to the thermodynamics, that state and path function, right? State and path function. Whenever we are taking any of the systems, right? Any of the systems, we can define the state of a system using some of the parameters, right? What are they? There are four major variables which is used to describe or determine the state of a system. What are they? Pressure, volume, temperature and number of moles, right? Pressure, volume, temperature and number of moles, N. These are the four parameters or variables which is used to describe or determine the state of a system, right? So they are called as state variables. What they are called? State variables. Clear? Yes, fine. Now, we have studied about the thermodynamic state of a system, right? Now, based on the state and path, we can define the functions into two types. They are state functions as well as path functions, right? State functions as well as path functions. So, we can define a function as a state function, which means that it depends on the state, which means initial and final state, but it does not depend on the path. I will explain. State function means it depends on the initial and final point but not on the path. They are called state functions. For example, if I am taking pressure, volume, temperature or internal energy will be detailedly studied in the next session. It is described as U, right? It is a type of energy. You will be explained or you will be learn from the next session onwards. So, in the case of pressure, volume or temperature, if I am saying that if you want to find the pressure, initial and final state of if the initial and final state of a pressure is given, you can find out the change in pressure, right? Delta P is equal to P2 will be the final pressure and P1 will be the initial pressure, right? So, we can find out the change in pressure as P2 minus P1, which means final minus initial state. That type of functions which can define by using initial as well as final point of the state are known as state functions. Clear? Similarly, you can take delta V is equal to V2 minus V1, right? Then temperature is also delta T is equal to T2 minus T1, which means they are depends on the state. As you can see over here in detail, in the tomorrow session you will take that delta U is equal to U2 minus U1 also, right? Clear? Okay, fine. Now, what about the path functions? Whether it is depending on state or not. What about the path functions? This is again another type of functions, right? Again another type of functions in which It depends on the path, right? It depends on the path, which means that however they are reaching into the path. For example, by the system which goes from its initial to final state. The manner by which the system goes from its initial to final state is known as the path function. Is it clear? By the definition, is it clear? Okay, some examples are given here. Heat as well as work, right? Heat as well as work are the examples of path functions. I will give an example to find out whether work is a path function or not. For example, if I am going to any third or fourth floor of a building, right? One of my friend is going by lift and I am going by stairs. What will be the work done by those two people, me and my friend? Is it same or different? One is going by lift. Just assume it is a lift. Then another one is going by stairs, right? And both of them are reached at the third floor of the building. What will happen to the work done? Whether it is same or different? Maybe different, right? Because this person is using the stairs, so he is giving more energy to climb the stairs. But here lift means just pressing the number, right? So he will reach to the third floor or fourth floor, wherever he can go, right? So which means that the work done is depends on the path, how they are reached there, right? So we can explain that work is a path function. Is the point clear? Okay, I hope it was clear for everyone. Now let me move to the next topic, that is the thermodynamic properties, right? Thermodynamic properties. What do you mean by thermodynamic properties? And what is their classifications? What is their classifications? So, thermodynamic properties means the properties which affect on bulk of the system. Otherwise, these properties are again known as macroscopic properties. It depends on bulk, right? Macroscopic properties. Now, these properties can again be divided into two types. First one, it is the extensive properties. Extensive properties, right? Then second one, it is the intensive properties. What will be the difference? Any idea? It is already given here in this slide. Because in the case of extensive properties, it depends on the amount of substance that present on the system. Otherwise, quantity, right? It will depend on the amount of substance that present on the system. For example, mass, volume, internal energy, enthalpy, heat capacity. These are the examples of extensive properties. The properties that are depends on the amount of substance or the quantity is known as the extensive properties, right? And examples are given here: mass, volume, internal energy, enthalpy and heat capacity. Some other properties are also given here. You can just refer. So, mass, right? M, volume V, internal energy is represented by the letter U, right? U. Then enthalpy is given by capital letter H. Heat capacity is given by the capital letter C. So, there is a simple code or mnemonic to find out the extensive properties are MVUHC. Clear? Now, what about the intensive properties? Independent, right? Intensive means independent of the amount of substance. So we can say that the properties that are independent of the amount of substance or the quantity is known as the intensive properties. What are the examples? Temperature, density, pressure, and all the molar properties like molar volume, molar capacity, molar heat capacity, and so on. They are known as the intensive properties. Clear? Okay, you must have an idea about the examples of extensive as well as intensive properties. Many of the JEE Main questions ask from these topics whether you have to identify the intensive properties or extensive properties from the following some examples. Clear? Yes, fine. Now let me move to the thermodynamic process. What do you mean by thermodynamic process, right? I hope everyone have the idea about the different types of process, right? Different types of thermodynamic process. Can anyone please say what are the different types of thermodynamic processes? Just by name. Four types of process, right? Isothermal, isobaric, isochoric, and adiabatic processes. So let us start with one by one. First one, it is the isothermal process, right? Pooja, class will be end by 6. It's the 1 hour live session starting from 5 to 6. Okay, what do you mean by the isothermal processes? Iso means same, right? Iso means same. Then therma means anything related to temperature or heat, right? So I can say that temperature, right? So the process which is happening at the same temperature condition is known as the isothermal process. For example, I am taking the real life example here. As you can see here, this is the boiling of water, right? I hope everyone see in your home also. We are just boiling the water. In order to find out whether it is, in order to check whether it is an isothermal process, I am keeping a thermometer here, right? I am keeping a thermometer here to check the temperature. Then what will be your observation? What will be your observation? First, I will start heating the, this part, right? This container having water, I am just starting heating. After some time, it will start boiling, right? Then you can say that whenever I am keeping a thermometer here, you can say that temperature is remaining constant, right? After boiling the water, the temperature is remaining constant. It is about 100 degrees Celsius, right? 100 degrees Celsius, which is the boiling point of water. So finally I confirmed that the boiling of water is an isothermal process, which means that during the boiling of water process, there will be the temperature remain constant. It is around 100 degrees Celsius, that is the boiling point of water, right? So we can say that isothermal process is the type of thermodynamic process in which temperature remains constant, right? Temperature remains constant. So I can say that delta T, the change in temperature, right, should be T2 minus T1. Then what about T2 and T1 here? T2 and T1 is same, right? Because it is isothermal. So this will be 0, right? So the condition for an isothermal process is that delta T equal to 0, or the process which is happening at the constant temperature condition. Clear? Just let me know whether it is clear or not. Then only I can move to the next part. Now this is the second type of thermodynamic process, that is the isobaric process, right? Again, iso means same. Then what about baric? Pressure, right? Bar will be the unit of pressure. So I can say that this is the same pressure conditions, right? Same pressure condition. Again, I am taking another real life example here. I am just taking water or something, cooking food here, and boiling the water by using the lid opened, right? By using the lid opened. What will happen there? Okay, Pooja, which point I want to repeat? Isothermal process. Okay, here I am taking water which is used for boiling. After some time, during the boiling of water, when I keep the thermometer here, I can see that the temperature remains constant here about 100 degrees Celsius, which means that this process will be an example of isothermal process, right? Isothermal means the process which is contains at the same temperature condition, which means here the temperature is found to be constant around 100 degrees Celsius. Clear? Okay, now let me move to the second process, that is the isobaric process. Yes, work done also same. We will be discussing work done on different processes in detail in the next class. That's why I didn't give any idea about that. Okay, work done is also same here. Now, what about the isobaric process? Isobaric process. Same pressure, right? Same pressure. And this is the real life example. Again, I am just boiling the water by using the lid open, right? What will happen there? What will happen to the pressure? Whether pressure increases or decreases? Or is there any change happens for the pressure? Okay, we can say that the pressure neither decreases nor increases, or neither increases nor decreases. Pressure will remain same. Right? Pressure will remain same. So I can call this process as an isobaric process, which means that delta P. Delta P means change in pressure, right? Pressure is a state function, right? So we can say that P2 minus P1, where P2 is equal to P1, right? For the same pressure condition. Now what will happen here? P2 minus P1. P2 and P1 are equal. So P2 minus P1 will be 0, right? So this is the condition for an isobaric process, that delta P is equal to 0, right? Delta P is equal to 0. Clear? Right. Now the third process, we have just discussed about the isobaric process, which means it happens in the same pressure condition. So the condition will be delta P is equal to 0. Whenever you see that delta P or the change in pressure is equal to 0, you can identify that process as an isobaric process. Right? Now the third one, it is the isochoric process. Isochoric process, right? Iso means same, core, that is related to volume, right? That related to volume. So I can say that this is the type of process in which same volume or the volume remains constant, right? Volume remains constant. The same water I am heating or boiling here by closing the lid, right? By closing the lid. In the previous case, I have just opened the lid, right? Here I am just closing the lid. What will happen to the volume? Whether the volume increases or decreases? Lid is closing, right? Here I am closed the lid. So I can say that there will be no change of volume, right? Volume will be remain constant. Okay, volume will remain constant. So I can say that this is an example of isochoric process. So what will be the delta V here? Again, volume is a state function, right? So we can take it as the difference between final state as well as initial state, that is V2 minus V1 is equal to 0, or delta V is equal to 0 is the condition for an isochoric process, right? Isochoric process. Clear? Okay, now let me move to the last type of process, that is the adiabatic process, right? Adiabatic process. Is there any idea about the adiabatic process? Which term will be same here, or what will happen in this adiabatic process? Right, as you can see here, this is a container, right? I am taking a container here. I can say that this is an insulating wall, right? Insulating wall. Okay, this is an insulating wall, which means that there is no any heat exchange, right? There is no any heat exchange. But as you can see here, there is a piston is there, right? This will be the piston. If I am moving the piston down, what will happen? It will start contracting, right? Whenever I am moving the piston down, it will start contracting. If I am expanding this one, no? If I am taking up the piston, it will happen expansion or contraction, right? Expansion or contraction happens here, which means that here due to the presence of insulating wall, there will be no exchange of heat, right? There will be no exchange of heat. That type of process is known as the adiabatic process, right? So we can say the condition as, if I am representing heat is equal to Q, right? Heat is equal to Q. So I can say that Q, or the change in Q, is equal to delta Q is equal to 0. Because there is no any heat exchange. Clear? Right, in the case of adiabatic process, there will not be any heat exchange, so we can explain the condition as Q is equal to 0 or delta Q is equal to 0, right? Simply you can say Q is equal to 0. Heat exchange is equal to 0. Then, so far we had discussed about the thermodynamic process, right? Starting from the isothermal process, which means at the same temperature condition, the condition will be delta T equal to 0, right? Then we will move to the isobaric process. What do you mean by isobaric? Related to pressure, right? Same pressure conditions, which means delta P is equal to 0. And third one, it is the isochoric process, right? There will not be any change in volume. So delta V is equal to 0 is the condition for isochoric process. The last one, it is the adiabatic process, which means that there is no any heat exchange, or Q is equal to 0 is the condition for adiabatic process. Clear? Now, this thermodynamic process can again classified into different types, that is reversible as well as, okay. Before that, I will give a summary about this. So here, isothermal, right? Isothermal means temperature is equal to constant, which means delta T is equal to 0. So if I am taking here, this is the ideal gas constant, ideal gas equation, right? PV is equal to nRT. So if I am taking the process in a constant temperature condition, I can say that N is the number of moles, it will be a constant, and R is again constant, right? Gas constant. So T is the temperature is again constant here. So I can say that PV is equal to a constant here, right? PV is equal to a constant here. So from that I can identify that pressure is inversely proportional to volume, right? Pressure is inversely proportional to volume. Or I can say that whenever I am drawing the graph, right? Just like this will be the pressure, this will be the volume. So I can say that this will be the, as the pressure increases, volume decreases, right? This will be the PV graph for the isothermal process. Clear? Now again here adiabatic process, which means Q is equal to 0, right? Q is equal to 0, which means heat exchange is equal to 0. Then third one, isobaric, right? Pressure is a constant here, so delta P is equal to 0. Again, if you are applying the ideal gas equation here, right? PV is equal to nRT. Then I can say that V by T is equal to P by nR, right? V by T is equal to V by T, right? nR by P, sorry. nR by P, right? Then again, N is a constant, R is a constant, P is also a constant for an isobaric process. So V by T is equal to a constant, or we can say that V proportional to T. As the volume increases, temperature also increases for an isobaric process, right? Then what about the graph here? Pressure volume graph. Pressure remains constant, right? So this will be the graph PV diagram for the isobaric process. The last one, isochoric, means volume is constant, right? Volume is constant. Then whenever you are taking the ideal gas equation here, you will get as P by T is equal to nR by V, that is equal to a constant. Then what about the graph? Volume remains constant, right? So this will be the PV diagram for the isochoric process, right? Clear? Okay, now let me move to the different types of classification, again based on the thermodynamic process. Again, this is classified into two types. One is reversible and another one is irreversible, right? One is reversible and another one is irreversible. What do you mean by reversible process? Reversible process. As you can see here, I am giving an example, right? If I am giving you an ice cream, right? If I am giving an ice cream and I am saying you like that, just keep it for some time, don't eat. Then what will happen to that ice cream? If it is kept for some time, what will happen? It will start melting, right? If it is kept for some time, it will start melting, right? Fine. Now if I am keeping the same water, right? It will start melting, it will become small amount of water, right? Now I am keeping it in a refrigerator for some time. Then what will happen it again? It will again come back to ice, right? It will just freezing and come back to ice. If I am cooling here, it will become ice, right? Water is freeze to form, it's ice form, right? So such type of process in which that can be reversed back. For example, ice is changing by melting to water, right? Whenever I am keeping in the refrigerator, when it is cooling, it will again come back to ice form, right? So the process, the thermodynamic process in which it can be reversed back to its original state is known as the reversible process, right? Reversible process. Clear? Hi Aryan, good evening. Clear now? What about the reversible process? Whenever any of the process, if we are possible to reverse it back to the original state, we can call it as a reversible process. Example is given here. Now, what about the irreversible process? What about the irreversible process? An example is given here, right? Do you getting any idea about the irreversible process by using this example? Irreversible process. An egg, right? I am taking an egg, then I am making an omelette or anything, right? A fried egg is forming here. Now, this is staging, right? Egg is staging here to fried form, right? Then, is it possible to make this fried again back into the original state? Is it possible? No, right? Just like ice to water, we cannot be converted back into, yes, we cannot be converted back into the fried egg into the original one, right? So, such type of process are known as irreversible process, right? In the forward one, we can possible, right? This egg can be converted into fried egg, but it cannot be converted back into the original egg. So, we can say that the thermodynamic process, if we are considering the same thing in the case of a thermodynamic process, the process which cannot be reversed back, into its original state is known as irreversible process, right? Irreversible process. Clear? Yes, fine. So, we have discussed about the different type of process, right? Here we can divide these process into reversible as well as irreversible. As you can see here, whenever any process that can be converted back into its original state, it will be called as the reversible process. And if it is cannot be converted back into the original state, we can call it as an irreversible process, right? Clear? Okay, that's all about the thermodynamic terminologies. Now let's have some practice questions here. Here is the first question. Which of the following is not a state function? Which of the following is not a state function? We have discussed about the state function as well as path functions, right? State functions as well as path function. State function means it will be depends on the state, right? Final as well as initial state, it will depend. So we can find out the change in that particular function by taking their final and initial values, right? So here the options are given as internal energy, heat, enthalpy, and none of the above are the options given here for which of the following is not a state function. What will be the answer? Internal energy, heat, or enthalpy? B, right? Heat. Because heat is cannot be depends on the initial and final state, right? It cannot be final or initial state. So we can call it as a path function, right? Clear? Path function. So option 2, heat will be the correct answer here. And internal energy as well as enthalpy are the examples of state function which will depends on the final as well as initial state, right? Yes, heat is path dependent. Now, here is the next question. The question is based on the intensive and extensive property. Here, some examples are given here. Which of the following is an intensive property? intensive property. You must have an idea about what you mean by intensive property. Then what are the examples? Options are given: mass, volume, density, right? Mass, volume, density, or none of the above. Which will be the answer? Option 3, Aryang. Then option B is also there, right? Yes, option B. Yes. Option 3 is the correct answer. Those who are giving the answers like option B, just check here. Okay. Density you know, right? What is the formula to find out the density? Formula to find out the density. Mass by volume, right? Mass by volume, yes. Mass by volume is the formula to find out the density, right? So, there is one more important point you have to be noted or keep in mind that whenever you are dividing two extensive properties, right? Mass is an extensive properties, right? Extensive means it is depends on the amount of substance. Then, mass is an extensive property. Then, what about volume? It is an extensive or intensive property? Volume. Whether it is depending on amount of substance or not. Extensive, right? Again, volume is also extensive property. So we can say that there is a one more point that whenever we are dividing two extensive property, the resulting term will be an intensive property, right? Resulting term will be an intensive property. Right? Clear? Clear? So we can say that here option 3, density will be the correct answer, right? Now here is the last question. It is based on the different type of process, right? Process is given here, condition is also given here. You have to match the following. Match the thermodynamic process taking place in a system with the correct conditions. Then delta W is given. Here is the change in volume, change in work, right? W is the work and Q means it is the heat transfer. Delta U means change in internal energy. Okay, what will be the answer? Any options are not given here. Adiabatic process, right? In the case of adiabatic process, I have already mentioned that there will not be any heat exchange, right? There will not be any heat exchange. So, adiabatic means delta Q is equal to 0, right? Yes, correct. Then what about isothermal process? Isothermal process, like I have given a condition, right? Delta T is equal to 0, right? So, on the next class, you will get an idea about that, how temperature is related to internal energy. Now, you must have an idea that whenever delta T is equal to 0, delta U should also be 0, right? Delta U will be 0, right? So, here I can say that isothermal is equal to delta U equal to 0. Then what about other conditions? What about other conditions? Isochoric, right? Which means constant volume, right? Isochoric means constant volume. Is delta V is equal to 0. Again, in the next session, I will be discussing about the work done for the different process, right? So, work done is equal to P into delta V, where P is the pressure and delta V is the change in volume. If I am taking any isochoric process, which means P into delta V is 0, right? So, P into delta V becomes 0. So, I can say that work is equal to 0, right? Work is equal to 0. Work done 0. Then what about the last one? The remaining, right? Isobaric. Isobaric means pressure. There will not be any change in pressure. Delta P is equal to 0. So, delta P is equal to 0. So, I can say that heat exchange will not be 0. That is delta Q not equal to 0 and delta W not equal to 0. Clear? Yes, fine. So, that's all about from my side for today. Again, the remainder about the All India test series for the JEE Main Session 2 and JEE Advanced 2025. Just enroll fast. By using this U250 of code, you will get the discount of 2,999. So, enroll fast, don't miss it. Okay, so far we have just discussed about the basics of thermodynamics, right? We have studied about the thermodynamics terms starting from the system and the surroundings. Then what you mean by system, what you mean by surrounding, how they are separated by using boundaries, right? So, finally we were moving to the different thermodynamic process starting from isothermal, adiabatic, isochoric and isobaric. Then we studied about the state functions and path functions, right? State functions and path function. Then keep it reminding on their examples also. The last one we have studied about the extensive as well as intensive properties, right? Again, the examples of extensive as well as intensive properties also repeated questions in the JEE Main questions, JEE Main paper. So, keep on mind on this. Anyway, thank you so much all of you. And tomorrow I will be coming back with the next part of the thermodynamics, which is about the heat and work. Till then, bye-bye all of you. Then, don't forget to subscribe our channel. Do like, share this particular session to your friends and family. Bye-bye all of you. Take care.